Let us start with lesson 5 and have an overview of the Azure Resource Manager. So there are two methods of deploying Azure resources. The traditional approach, referred to as the Azure Classic Deployment Model, relies on the service management APIs. While classic deployment still exists, we recommend using the newer Azure Resource Manager deployment model for any new deployments. So in this particular lesson, we'll cover both deployment models, including the difference between them and considerations for scenarios that involve interaction between their respective resources. However, in this course, the emphasis is on the Azure Resource Manager model, since this is the current prevailing deployment method. So after completing this lesson, we'll be able to describe Azure Resource Manager, explain resources and resource groups, and describe Azure Resource Manager deployment methodologies. So let us start with understanding what is Azure Resource Manager. The service management deployment model was the original deployment model available in Azure. However, as Microsoft Cloud technologies evolved and matured, the original model required a significant redesign. Its successor, Azure Resource Manager, introduced a new approach to deployment and management of Azure services, focusing on the concepts of resources and resource groups. Resources represented individual building blocks of Azure-based solutions, and resource groups provided a way to group these resources into logical containers. Azure Resource Manager introduced a new deployment method, which is based on deployment templates. A template is a JavaScript object notation, that is JSON formatted file, that defined a basically a resource collection that you intend to implement in the same resource group. The resulting deployment populates the target resource group according to the template's content. Azure Resource Manager also fully supports role-based access control. This mechanism relies on predefined and custom-defined roles to grant Azure AD users and groups the necessary permission to conduct role-specific actions on a subscription resource group or a resource level. Tagging is another benefit of the new management model, and it involves assigning custom labels to resources and resource groups. You can utilize this to document your cloud environment. For example, you can identify a resource as part of your production, test, or development environment. In addition, billing data includes tags, which allows you to identify the cost associated with tagged resources. Azure Resource Manager also includes support for policies and locks to further control the management and deployment of individual resources. Policies allows you to define additional conditions that restrict actions that users can perform on resources to which they have role-based access control based permissions. For example, you can prevent users from creating resources without assigning a specific tag to them. Similarly, you can restrict the sizes of the VMs that users can provision or restrict location to which users can deploy such VMs. Policies take form of JSON formatted policy definition files with a straightforward syntax. To create a policy definition, you can also use PowerShell commandlet such as new Azure RM policy definition commandlet or a command line interface commandlet, that is Azure policy definition create command. Alternatively, you can also use REST API for this purpose. After you have created a policy definition, you can assign it to an individual resource, a resource group, or an entire subscription. The primary purpose of a lock is to prevent accidental modification or deletion of resources. So once you assign a lock to a resource, deleting it requires additional explicit steps by a user with sufficient privilege to override the lock. So there are two types of locks. One is read-only and the other one is delete. So read-only lock prevents modification within the scope where the lock is assigned. Delete lock prevents deletions within the scope where the lock is assigned. So you can assign a lock to a resource group, or a subscription level. The most straightforward ways to create and assign a lock is directly from the Azure portal. Then you have the Azure Classic Deployment Model. The Azure Classic Deployment Model was originally referred to as the Service Management Model, which was introduced in 2009. This model served as the primary method of deploying and managing Azure services until the introduction of Azure Resource Manager. While there are numerous differences between the two models, we will only focus on the differences applicable to infrastructure as a service. So in this context, the primary concept that distinguishes service management from Azure Resource Manager is cloud service. A cloud service is a logical container hosting one or more VMs. Besides enabling the VMs to communicate directly with each other, it also allows to access them over the internet. This is possible because each cloud service automatically receives a public IP address and a corresponding publicly resolvable domain name system name. Typically, to access VM in this classic deployment model, you can create an endpoint by modifying the cloud service where this VM resides. So each VM exists within the boundaries of a cloud service. Cloud service also allows for grouping of VMs into availability sets and thereby providing resiliency against hardware failures and the continuity of service during occasional maintenance events in Azure Data Center. Hardware failure resiliency relies on placing VMs into two distinct fault domains, with each fault domain representing separate server racks. Continuity of service involves placing VMs into 5 update domains. The platform ensures that separate fault domains are never updated at the same time. Cloud service also provides load balancing functionality. By using a load balanced endpoint, cloud service distributes basically incoming traffic and targets a specific port across VMs within the same availability set. In addition, cloud service handles network address translation, that is NAT, which allows for connectivity to individual VMs via its endpoint. Optionally, you can also create a virtual network in Azure and deploy VMs in the classic deployment model into the virtual network. This arrangement allows you to provide direct connectivity between VMs that do not reside within the same cloud service. Creating a virtual network and deploying VMs into it is also necessary to establish direct connectivity between Azure VMs and on-prem networks. So while all services that you provision by using Azure Classic Deployment Model belong to a resource group, you cannot directly assign them to a specific group at the time of provisioning. However, in some cases, it is possible to move resources across resource groups. For example, this functionality is available with Classic VMs. So Azure Classic Deployment Model does not support a variety of Azure Resource Manager specific mechanisms such as tags, policies, or logs. It is, however, possible to use role-based access control to control access to classic resources. Moving on, let's go ahead and talk about resources and resource groups. So every Azure resource belongs to a resource group. You can choose to create a new resource group or to use an existing resource group when creating a resource. So when you deploy a solution that consists of a few resources working together, you should create a dedicated resource group so that you can manage the life cycle of all the related assets by using this resource group. You can add or remove additional resources from the resource group as your app evolves. How do you create resource groups and add resources to it? You can add resources to a resource group at any time. The Azure portal provides an option called as Add that you can use to add new resource to a resource group. Deleting a resource group will delete all the resources contained within it. Azure Resource Manager Azure PowerShell module allows you to manage resource groups in your Azure subscription. You can create resource groups by using new Azure RM resource group commandlet. You can then use resource type specific commandlets to create resources in that resource group. You can also use a deployment template to add resources to a resource group. Azure command line interface offers equivalent capabilities similar to Azure PowerShell. You can even move resources. So if you want to move resources between resource groups, you can go ahead and do that in terms of resource group capability provided by Azure. So you might use it for several reasons, such as Azure, a resource basically needs to be located in different logical grouping, or Azure subscription. A resource does not share the same life cycle with other resources that were in its group. It is very important to consider the factors when you are moving a resource. You cannot change a resource location. After you create a resource, it must remain in the same data center. You should group resources only with other resources that share the same life cycle. You should use the latest version of Azure PowerShell if you want to use it to move resources. Both the source and destination resource groups are blocked for deletion while the move operation takes place. The ability to move resources is limited to specific resource types. Now let us move forward and talk about various Azure Resource Manager deployment methods. So in the past, deploying Azure-based solutions relied on the imperative approach. This meant that the provisioning process consisted of a sequence of steps, with each of them creating individual components of the solution. The new programming interface of Azure Resource Manager facilitates support of a new declarative deployment method based on Azure Resource Manager deployment templates. In this context, a template is JSON formatted file that defines a collection of resources that you intend to provision in the same resource group. The resulting deployment populates the target resource group according to the template content. While the traditional deployment method that rely on the GUI or scripting and programming languages are still available, templates offer additional benefits. Similar to scripts, they facilitate deployment of multi-component solution in an automated manner. However, unlike scripts, they do not explicitly specify individual steps required to provision these solutions. Instead, they simply define their intended end state. So this way they rely on the intelligence built into the Azure platform to deploy all necessary resources in the most optimal way. This results in minimized deployment time and reduces the potential for errors. You have the option of defining dependencies between resources to control the resource provisioning sequence. Deployment templates are ideal if you need to provision multiple solutions with the same general design. For example, you can use the same template and deploy it to separate resource groups representing development, test, quality assurance, and production environment. So to account for any potential differences between them, you can replace specific values in the template with parameters and then assign values to these parameters at the deployment time. Templates are idempotent, which means that you can deploy them multiple times to the same resource groups and the outcome will always be the same. This accommodates scenarios where you want to recreate an original deployment or remediate any issues resulting from past deployment changes. Templates support VM extensions, and basically these VM extensions allow you to configure operating system within Azure VM. These extensions include several configuration management services such as Windows PowerShell desired state configuration, Chef, or Puppet. So now we will move on to lesson 6 and we will talk about Azure Management Services.